In this video, we shall be solving for x in this fine combination of linear function, exponential function, and also logarithmic function that forms an equation. Before I proceed, I would like you to like this video if you find it interesting. Subscribe to my channel if you haven't done so. Share this video. Then leave your comments in the comment section. If I take log to base 6 of both sides, I have log to base 6 of x is equal to log to base 6 of 12 raised to power log to base 6 of 8x. Now, I will apply a law of logarithm, which is called the power law. It states that if I have log to base a of b raised to power p, it will be p log to base a of b. More like this power will come down and multiply the log. Now, log to base 6 of x will now be equal to log to base 6 of 8x times log to base 6 of 12. Now, I will apply another law of logarithm where I'll have to separate these two. So here it becomes log to base 6 of 8 plus log to base 6 of x in a bracket will now be multiplied by another bracket log to base 6 of 6 plus log to base 6 of 2. The law I applied here is the product law. The product law of logarithm simply tells us if I have log to base a of, say, m times n, it will be the same thing as log to base a of m plus log to base a of n. So this law is applied in this case and in this case. Let's remember that 6 and 2 are factors of 12, as 8 and x are factors of 8x. Now to proceed, I need to simplify this further. Now, log to base 6 of 6 is 1 because log to base a of a will always give us 1. So I'll write 1 here in place of log to base 6 of 6. So proceeding, log to base 6 of x will now be equal to, my 8 can be written as 2 raised to power 3. Now, applying this law of logarithm, that is the power law, the 3 will come down, giving us log to base 6 of 2 plus log to base 6 of x in a bracket, and this is 1 plus log to base 6 of 2. So we now need to open the brackets. If we open the bracket, this times this will give us this log to base 6 of 2, and this times this will give us 3 log to base 6 of 2 all squared, because the argument and the bases are the same, so I have to square them. Now, log to base 6 of x multiply 1 will give us log to base 6 of x. Now, log to base 6 of x times this will give us log to base 6 of 2 times log to base 6 of x. Now, this and this are equal, and because they are in opposite sides of the equation, they are equal and opposite. So I'll now have to take this term containing the unknown to this side. So minus log to base 6 of x times log to base 6 of 2 will be equal to 3 log to base 6 of 2 plus 3 log to base 6 of 2 all squared. Let me factorize log to base 6 of 2 out. Log to base 6 of 2 bracket 3 plus, now one of these will remain, log to base 6 of 2 equals to minus log to base 6 of x times log to base 6 of 2. Now, this and this will cancel out because they are the same factors. So what I have left is minus log to base 6 of x being equal to, now this 3 will be written as 3 log to base 6 of 6, because log to base 6 of 6 is 1, plus 3 log to base 6 of 2. Yes, I did not remember to put this 3 here, so I have this. Now, I am going to apply this power law back again. So log to base 6 of 6 to power 3 plus log to base 6 of 2 to power 3 will give me minus log to base 6 of x. 6 to the power 3 is 216, so I have log to base 6 of 216 plus. Now 2 to the power 3 is 8, so I have log to base 6 of 8. And this is minus log to base 6 of x. Also applying the power law here, I have log to base 6 of x to the power minus 1 equals to, now I will now apply the product law of logarithm here in this place. That becomes log to base 6 of 216 times 8. 216 times 8 is 1728. This is log to base 6 of x to the power minus 1. So this will cancel this, remaining x to the power minus 1 equals to 1728. So x will now be 1728 to the power minus 1, and x equals to 1 over 1728.